Determine the domain and the range of the following functions. Welcome to another video, and this is a domain and the range of a function part 2. So the link for part 1 is available in the description of this video. And because this is a function, so let's see a quick review. When they say function, we see a function as a machine. Okay, everything we plug in the machine is the input or the domain, which is the x values, and everything we get output or the range, which are the y values. So if we go back to the question, the first question here, we have f of x equals x squared. That's the function. So the domain and the range. You have to understand that when they say f of x equals x squared, so this is same as saying y is equal to x squared. So the f of x represents the y. Okay, that's the name of the function. And for that, we call this a polynomial. So this is a polynomial, okay? And as a polynomial, the domain is all real numbers. So as an interval notation, we write it like this. So negative infinity, comma, infinity. So this is telling you that they use a value and they raise it to the second power. So we can use any value and raise it to the second power. That's why the domain here is all real numbers. Now the range is the trick part. So to find the range is very important to have an idea how the graph of the function looks. Okay, so this video is not to graph the function. That's why I just put this. We can see in a different video how to graph a function. So if you see this graphic here, so for the range, we are looking for the y value. Therefore, what we need to check is the lowest point of this graph. So the lowest point here has y value 0. And the graph doesn't have an end. So the arrow is telling you that it keeps going up. The reason we have the interval here as 0, comma, infinity. So 0 is the y value. So the lowest y value is 0 for the graph. And the highest y value, we don't know it. So it's going up. That is infinity. So let's see the second function. So here we have a g of x equal to x minus 1 divided by x plus 3. So again, understand that this is same as y is equal to, okay, 2x minus 1 divided by x plus 3. So we call this rational function. So rational function. Okay, so that function looks as a fraction, something divided by something. So the domain here is all real numbers except negative 3. Why except the negative 3? Okay, the thing is this. We can plug any value, but if you plug negative 3 in the function here, you'll see that the denominator will be negative 3 plus 3. So the denominator of the function is x plus 3. So the denominator is x plus 3. If you replace x by negative 3, we're going to have negative 3 plus 3, and that is 0. So every time you have a fraction and the denominator is 0, we say that this is undefined. And even if you check with a calculator, right, you have something divided by 0, calculator will tell you error. So it is undefined. So we cannot use negative 3 as an input for this function. The reason the domain will be all real numbers except negative 3. And as interval notation, yes, we have a negative infinity, comma, negative 3, union, negative 3 to positive infinity. So you have to understand that this is like a number line. And as a number line, we have a 0, we have a 1, we have a 2, we have a 3, and so on, okay, going to infinity. The other side, we have a negative 1, negative 2, negative 3, negative 4, also go to negative infinity. Okay, so understand that when we say -3 is not in the domain, so it's like at the -3 we have an open circle. So -3 is not in the domain. Therefore, anything between -infinity and -3 is in the domain. That's why we have -infinity, comma, -3 union. So the other side, okay, -3 is not included to infinity. And at -3, we have to use open parentheses. Same thing for -infinity and infinity. They are not closed because they are not in the included in the domain. So that's why we use open parentheses. Now the range. So again, we need the graph to see clearly what is the range here. So you could understand that if blue line, blue line we have here is a line passes through y value as +2. So that y value +2 will not be in the range. The reason we have a -infinity, comma, 2 union 2 to infinity. Again, when they say range, we are looking for the y value, and the y equals 2 is not in the range. The reason we have that line with the blue line, across y value equals 2. Okay, so if we continue to the next function, we have here h of x equal to parentheses x minus 1 squared minus 2. Again, understand that this is y equals to parentheses x minus 1 squared minus 2. And this is, again, a polynomial. So as a polynomial, okay, the domain is all real numbers. So no problem. But the graph is, again, this we are seeing here. So a parabola, we call it a parabola. And it's a graph where we have the top, still going up. So there is no end. The domain -infinity to infinity because we have here all real numbers. The range, so the lowest y value, the lowest y value here, which is this point here with -2 for the y. Okay, so the lowest y value is -2, and the highest y value we don't know, so it keep going up, so infinity. So it's like from this up. So always the range or the domain, we write from the lowest value to the highest value. The reason we have a -2, comma, infinity. But you have to understand that -2 is included in the graph. The reason we use square brackets, so we close it at -2. If it's not in the graph, we're going to use open parentheses. Okay, so this is the range. And again, when you have a function, the tricky part is to find the range, because that, to clearly see this, you need the graph to see how the graph looks, and that will help you to find the range. Let's see the next function. Okay, this is a square root function. So you have a square root of x plus 4. And the domain here is -4, comma, infinity. So as a square root function, you have to understand that to find the domain, you're going to set what you have inside, which is here x plus 4. You said that is greater than or equal to 0. So the thing is this, as a square root function, we cannot find square root of a negative value. So we have to make sure that x plus 4, any value we're going to plug into x, when we compute that x plus 4, we don't get a negative value. But it can be 0 inside, yes, because square root of a 0 exists. And the same thing, it can be a positive number because square root of a positive number exists. But square root of a negative number does not exist for real numbers. Therefore, we have to make sure x plus 4 is greater than or equal to 0 when we plug x. So we need to solve for this x. Therefore, we're going to subtract 4 on both sides. So you'll see that you're going to have x is greater than or equal to -4. Okay, so because x is greater than or equal to -4, as an interval notation, we say -4 because that is included, comma, infinity. So this is telling you that if you have a number line like this, and you have a -4 somewhere here, okay, let's say we have a 0 here. So from -4 to the right side is the solution. Okay, that's why you have a -4, comma, infinity. So we close at -4, but we open it at infinity. We don't close there. Now the range, again, if you see this blue graph, the lowest point of the graph, which is here, let's show that, yes. So that's the lowest point of the graph, and the y value of that lowest point is 0 because the point is on x-axis. So any point on the x-axis has y value at 0. Okay, so that's why we have a 0, comma, infinity, because the graph is going up and there is no end. So infinity, yeah. So that goes to infinity. That's the range of the function. Yeah. Let clarify something else. I think there's the beginning here for this function b. When we have a 2x minus 1 divided by x plus 3, and we say, okay, the domain we have all real numbers except -3. Okay, there is something I have to clarify here. Okay, which I didn't. So the reason we say -3 is not in the domain, which is that, okay, -3 will change the x plus 3 to 0. Okay, there is a way you can check to get that -3. So you set, so every time you have a rational function, you set the denominator. The denominator here is what? X plus 3. So we set the x plus 3 equal to 0. So set this equation means we want to know the value of x, which will change this x plus 3 to 0. So you subtract the 3 on both sides. That's the way we're going to solve for x. So we get x is equal to -3 because -3 and the +3 here gonna cancel out. So that's the reason, if you cannot find this mentally, okay, you set the equation to solve for x. So that's it for any rational function you have. You set the denominator equal to 0 to solve for x. Now, if you know the x value, what you will do is that you're gonna take it out from the domain. The reason we say all real numbers except -3. Now, if you go back to our function, okay, so like we said it here, we have this polynomial and the all real numbers for the domain, but the range is -2 to infinity. Okay, this one square root we set inside greater than or equal to 0, we solve for x. Okay, here this is the last question, and we have m of x equal -x squared. Okay, so you have to understand that it's not always, you will see the range as 0 to infinity. The range also can be -infinity to infinity, or it can be -infinity to 0. The reason we have this question here. So have a -x squared, which is again a polynomial. Okay, the domain will be the all real numbers. So -infinity to infinity, because this is an interval notation. So the range, if you see the graph, you will see that this time the lowest point, the lowest point of this graph is keep going down. Okay, it keep going down. So the lowest point here, we don't know it. So that's why we use this -infinity, because it's going down. So -infinity, but we don't close it at -infinity. But the 0, okay, the top of the graph, this time is the highest point. This time is the highest point, and that highest point has y value 0, okay, and we close it at that. So understand that if you write this range as a 0 to -infinity is wrong. Why? Because always we need it from the lowest value negative infinity to the highest value based on the graph. So our next video will be how to evaluate piecewise function. So feel free, to like this video and subscribe so you can get the next video. Understand that overall, practice makes perfect. Practice until you get it. So thank you, and see you in our next video.